Hello friends, I am Mr. SET, Mr. Set. It's nice to meet you all. I will be your companion in this video and I'll be teaching you operations on sets in Python. Um, as this is my video, let me tell you a short story about myself. I study in a school where I have a fat, wicked senior who always bullies me and gets his work done from me. Very recently, he told me to form a soccer team from amongst the students of our school. But the trouble was, he kept on imposing 1,000 conditions to make my life miserable. I was completely muddled, but some good friends recommended me code sculpture, and with a bit of programming, my poor life was saved. And what's more, I was so thrilled on getting the results that I decided to share my experience with you all. Hope you like it. First thing first, who am I? I am a set, so let me tell you something about myself. No matter how much you try to put me in order, I will always be unordered. Also, I do not have anything duplicate inside me. For example, let me show you my stomach. Over here you see my stomach. This photo contains 3 oranges. But hey, that's not possible because in this case, the oranges are duplicate, so it's not possible. Whereas the photo on the right side contains 1 orange, 1 apple, and 1 grape. So that's quite possible because in this case there's no duplicate. Alright, so coming back to the problem, the fat senior provided me with some collection of names like these: Sam, Roy, John, Julian, Ronnie, and Drake. It was told that Sam, Roy, and Julian were good runners. It was also told that Roy, John, Ronnie, and Drake were strong boys. Now, I thought about grouping these boys with common characteristics into sets. Now, you can also group objects with nothing in common in sets, but then the whole purpose of grouping them gets defeated. So I grouped the boys based on their common characteristics and formed sets. I did that using the set function. So here are the sets that I formed. The first set, let's call it set GR because it represents good runners, contains Sam, Roy, and Julian. The second set, let's call it set SB, contains Roy, Drake, John, and Ronnie. These two sets characterize these boys based on their common characteristics. That is, these boys are good runners and these boys are strong boys. Alright. Um, hey, who was the boy who was present in both the strong boy set and the good at running set? Alright, I'll use the intersection operation to find out the common boy. Intersection operation, as you know, is the overlapping of two sets. The overlap portion, which you see over here, means that the elements inside the overlap portion belongs both to set GR as well as to set SB. So Roy is an element of set GR, also it's an element of set SB. Alright, so that was Roy, who's both strong and good running. Now we come to union. So what is union? Like, if you want to know that who all are there in the soccer team till now, you have to create the union of two sets. That is, you have to club together all the information, all the elements in the two sets into one set, and that one set will have all the elements unique. You won't have any duplicate items inside that set. So, for example, we had set GR and set SB. We had the element Roy present in both the sets, but in the union set, this one or maybe this one, you have Roy only once. All the elements should be unique. Alright, before proceeding, let's go to explanation. Okay, so explanation part 1. GR is a set of 3 boys. Again, SB is a set of 4 boys. If you print GR and SB, it should print the names of these boys, and it does, yeah. Uh, uh, we come to the intersection part. gr.intersection SB will print all the elements that are common to both gr and SB. In this case, we had just one element, Roy, which was present in both gr and SB. So that gets printed. Okay. Now, had we done gr.intersection_update_SB, the output would have been same. The output would have been Roy because that's a common element. But the set gr would have been got mutated. The gr now just contains these values. But had we done in section update sp, its values would have been changed. It would have contained the new value Roy. The same thing with the union operator. gr.union_sb, it prints the union, the clubbing together of all the elements in the set gr and sb, as we see over here, and all the elements are unique. Now, had we done gr.update_sb, gr's value would have got mutated, and gr would have stored this set, the union of gr and sb. Alright, so we move on. Now, this wicked senior interrupted and said that I could keep anybody but Julian and John, as he did not want Julian and John to play because they did not work for him. I had to find out a way to do this. Luckily, I can use difference update in code sculptor. That results in the set containing all the values but the ones that we don't want. So in this case, we don't want John and Julian. So as you can see on your screen, we have a dragon eating up the value John and Julian from the set, and we are left with Sam, Roy, Drake, and Ronnie. Okay. Oh, again this fat man. At this point, my senior told me that the current goalkeeper Drake was rested for a few days as he was sure to be selected, and the reserve goalkeepers were given a chance to play in some practice matches. They included um, Scoop and Tim. Okay, so I looked up code sculptor and came up with this symmetric difference update. Now, what does this do? You see, I have two sets. This one is a set of goalkeepers, Tim, Scoop, and Drake. Set U is the one which we have been using till now. It contains Sam, Roy, and Ronnie and Drake. Now, symmetric difference update, it will figure out which element is common in these two sets, and it will remove that element from our set U. And the elements Tim and Scoop will be placed inside our set U. Okay, the next thing, as expected, I was again interrupted. This time I had to add the regular goalkeeper Drake and remove the part-time goalkeepers Scoop and Tim as they were reserve players. So what I did was I put inside my set U Drake and removed out Scoop and Tim. So my new set contained Roy, Drake, Ronnie, and Sam. Okay, um, now there was a math professor, and for satisfaction, the math professor wanted to verify whether all of the students who are playing passed in the maths examination. She gave me a set of all the students in the class who had passed in mathematics. Now this is the set of all the students who had passed in mathematics, and this is the set U which we are working with. I checked whether set U is a subset of set B, that is, whether all the elements of U are present inside set B. And yes, we can see that all the elements of U are present inside set B, so set U is a subset of set B. Now next, in came a recommendation from the physical training instructor that no matter what, all of the following students should be there in the soccer team because they were good players. The set that I received from the instructor was set B, this one. He wanted Roy, Ronnie, and Drake to be played no matter what. So I had to check whether the set U was a superset of the set B. That is, the elements of set B were present in set U, but all the elements of set U might not be present in set B. As you can see over here, all the elements of set B are present in set U. Therefore, U is a superset of set B, and the instructor was happy and my job was lessened. So we move on to the code sculptor again to discuss the explanation part 2. U, as you know, is a union of set GR and SB. We run the program and okay, the updated set, that is the union of set GR and SB, is set Sam, Roy, Julian, John, Ronnie, and Drake. That's U. Now I have a set J equal to which contains Julian and John. U dot difference update J and print U. What I'm doing here is I am removing Julian and John from my set because that was what the senior wanted. And sure enough, I have removed them. See over here, I don't have Julian or John. Now, okay, I had used difference update J. It means that while computing the set without Julian and John, I had also mutated the set U. But had I only used U.difference_J, that would have printed the same result, but the value of U would not have been mutated. Next, I have a set alter, which contains Tim, Scoop, and Drake, you know, the reserve goalkeepers. Now U.symmetric difference update alter and print U. This statement over here, what it does is it computes the common element between the set alter and U, that is Drake. It removes Drake and it introduces Tim and Scoop in my set U, and we print it, and sure enough, you see no Drake over here, but you have Tim and Scoop, so it's doing its work. Had we used U.symmetric difference alter, it would have also created the same result, but U would not have been mutated. Next, we are doing U.add Drake because we had to introduce Drake back in the set. Again, we are removing Scoop and we are discarding Tim. Okay, remove and discard basically do the same thing. They are similar. The difference is that if there is no element present inside the set, remove will give an error, but discard will not give an error. That's the only difference. Otherwise, they are absolutely the same. Now, we're printing that Scoop and Tim are removed and Drake is inside the set again. And sure enough, we see Sam, Roy, Ronnie, and Drake. The last portion. Over here, we are computing U.is_subset math fast. We are checking whether U is a subset of math fast. Math fast is a big set, and U is a subset of math fast because all the values in U are present inside the set math fast. The next one, U.is superset compulsory players. It's also true because all the values of compulsory players are present inside the set U. So U is a superset of compulsory players. The last one, I'm making a copy of the set U into U1, and if I print U1, it produces the same result as the set U. Okay. All right. So in this case, Python and Code Sculptor helped me save my life. In the last portion of a video, I have made a interactive application which is intuitive. You see over here, we click the run button and we are welcomed by a canvas screen. Do something intuitively. Okay, I press in section. You see the two sets. Oh my God, red and blue. They come together. The three values, Ace, Henry, and Jim, which were common, they are presented in the intersection portion only once. Now if I press union, they come together, and yeah, all the values of the two sets are poured into a big set union, and all the values are unique in this case. Alright, so I hoped you learned a lot from my video and it was entertaining. Goodbye from Mr. SET. Thank you.